Good morning, good evening, good afternoon, wherever you're hailing from. Welcome to another episode of Red Hat Advanced Cluster Management Presents. I am Chris Short, executive producer of OpenShift TV. I am joined by not the entire RHACM team, but close. Scott Behrens likes to bring the heat on these calls, so hold on tight. And Scott, I'll let you take it away with all the intros and everything.
Grab your hats, Chris. You know we like to bring the thunder, maybe a little bit, bring the pain. For those of you in the Northeast under 6 feet of snow, we're going to try to heat things up today with RHACM and some thrilling lifecycle scenarios around clusters and Submariner and disaster recovery. So really packed in a dream team. We keep setting the bar higher and higher, and your content keeps getting better and better. So we're just trying to keep up. And I just keep having to find brighter and smarter and more talented people to bring in here. So awesome. I'm going to kind of move around. So I got Randy. Go ahead and jump off and give yourself a quick intro.
Sure, Scott. Thanks. So my name is Randy Bruno Piverget, and I'm a software engineer from the Cluster Lifecycle squad here at Red Hat. And Cluster Lifecycle is one of a few squads working on advanced cluster management. And today I'll be introducing Red Hat Advanced Cluster Management.
Nice. So Randy's going to help set the table in just a minute. Let's introduce Ryan Cook.
Ryan Cook, I'm with the Office of CTO. Today I'm going to actually be showing off a new application we're working on called Scribe. What Scribe is going to allow you to do is to move data between clusters, do disaster recovery, and do fan outs of multiple clusters.
Nice. And I got Raf here. Go ahead.
Yeah, Rafael Spazzoli, OpenShift architect in Red Hat Consulting. And today I'm going to show you a disaster recovery scenario with CockroachDB and Submariner and RHACM.
If you've ever read an OpenShift blog that deals with disaster recovery, I'm certain Rafa wrote it. Or if he didn't write it, he co-wrote it, or he basically told someone to write it. But a huge brain trust of information there. We have another individual that hopefully is going to join after he literally puts out a fire, and that's Michael Elder, our senior distinguished engineer in RHACM. Been here since the start of RHACM when it was back under IBM's purview as MCM. So has been in this space for a couple of years. Hopefully it's all good on his end. And the fire alarms that we were hearing in the pre-call roll-up were just a bad joke.
I'm hoping they're false.
Yeah, false alarms. So with that, let's turn the mic over to Randy, who's going to kind of set the table in the cluster lifecycle, make sure people understand what we're doing in that space, and bring them back up to speed with RHACM building out clusters. Go ahead.
I got you, Scott. Just sharing the screen.
Beautiful.
Okay, cool.
Awesome. Got a couple of slides. Don't go to sleep, folks. We got demos queued up.
Very cool. So as I said before, I'll be talking a little bit about Red Hat Advanced Cluster Management from the perspective of a squad member from Cluster Lifecycle. And this will involve version 2.2 of our release, which is the most recent.
Coming out the beginning of March. He's getting ahead of himself. We still have about a month till GA.
Very good. A little ahead of myself, but let's get it going. Right, so advanced cluster management is just one part of the larger OpenShift container platform, right? But by building on top and leveraging the OpenShift container platform, ACM is able to bridge the gap between high-level container control via orchestration and basically the next logical step, which is high infrastructural level control of cluster scaling, workload and application management, policy-based governance, and monitoring, all from a single console, ACM.
That's it. We're the top of the cake. We're the purple icing on top.
Yeah, exactly. So essentially, ACM will be leveraging one cluster as a focal point for control, and we call this the hub cluster. And that's where ACM is installed. And through a process called importing, we then put other clusters under the purview of the hub, and we call this our managed clusters, right? So with advanced cluster management, we can import or manage Kubernetes clusters from major cloud providers like IBM, Amazon, Microsoft, and Google. And we're also capable of provisioning and installing all those clusters from the context of that hub cluster control plane. So from a single place. And you can also provision and create VMware clusters from that control plane. Bare metal assets or VMware resources, essentially on-premises resources, also from your hub cluster. And from your hub cluster, you can view your managed cluster health, you can deploy applications, you can enforce policy, and you can also target your clusters for upgrade, deletion, or deprovisioning. So a lot's going on from this control plane, and we wanted to give our developers the most amount of control and a sensible amount of ability to dive deep, but also have a high level of control from the console, so they don't have to do too much legwork. So I'm going to run by the environment right now, or ACM's provision use case. From OCP, or the OpenShift Container Platform, you can access an installed instance of ACM right from the application menu. And for this case, we're going to jump to cluster lifecycle. And today we're going to be provisioning a cluster and then upgrading one. Right now I have two clusters imported, my local cluster, which is basically the hub and an abstraction of the hub managing itself, and one that I provisioned earlier. Right now, I'm going to create another one.
This is great. So you've already got two on Amazon, right? On AWS, your local, and that imported one. So you can run through create. You're quickly getting into this scope where you're gonna have multiple clusters that might need to talk to each other, right? They might need some multi-cluster networking, right? Okay, cool. So show us what's happening here.
Absolutely. So you can see here, this is our creation wizard. Like I mentioned earlier, we wanted to abstract a lot of this process down, so that's very easy to just grab and go and create a cluster. But also, we want to give our developers the ability to access the YAMLs and to further customize how they want the installation to go. So right now, I'm going to provision for another AWS cluster. I have my provider connection, which is just my credentials for AWS already set up. And if I wanted to, I could go ahead and jump into my install config YAML and make further edits on the YAML directly, or the cluster YAML. I don't need to. So I'm just going to go ahead and create. And
look at that smooth interface, Patternfly rewrite that we got here in 2.2. You got provider icons, all the Patternfly bells and whistles, console elements just look awesome. Nice work there, Andy. And
that's a good point. This release, we spent a lot of time, most of our time, realigning the UI so that we matched the Patternfly styling that was already happening in OCP and create, not synergy, but a connected styling through the products.
Yeah, consistent experience, right?
Exactly. So yeah, so this is going to take some time to provision. Luckily, I already have this nice little demo cluster sitting around. And we can quite easily see when our cluster has an upgrade available. You can jump directly to the OCP console for the cluster, but you can also upgrade from your RHACM console by clicking this upgrade button and selecting your next version. Right, and once I do this, it's going to send signal to the cluster itself, and then the table will upgrade. This actually takes a moment, but once it gets back status from the cluster that upgrade is happening, this status will change to upgrading in process, or in progress. You'll see it here as well. And that takes just a few seconds.
Nice. So it's all integrated, tight, finish, look and feel, create, upgrade, destroy, detach, all the lifecycle things that you can do. You're at a point, Randy, where you've demonstrated a new problem, you know, like a new opportunity, we call it, where we can take advantage of these clusters and do multi-cluster things. I see Michael here, video on. Hopefully everything's okay at his house. There was a fire alarm going off. I want to
you decided to jump out on me a little bit.
Yeah, do you want to give yourself a quick introduction and help us understand where we're going next?
Sure. My name is Michael Elder. I work in engineering on ACM and wanted to introduce this concept from what Randy showed us, what ACM can do managing across many clusters. And we're going to see some really neat examples of what you can do with as many clusters. But I wanted to set up this concept of Submariner before we kind of see that end-to-end flow. Does that still make sense, Scott?
Yep, perfect.
All right, let me start my screen share.
So yeah, we're delivering a tech preview of Submariner in our RHACM 2.2, which is coming out in about a month. So kind of talk us through, like, what are we gaining there? What are the bells and whistles we're getting with Submariner?
Absolutely. And I still have a habit of calling it Submariner, and I know a lot of folks like to call it Submariner, and it wouldn't be a good community project name if there weren't multiple opinions on how to express it. So, leave your opinion in the comments and let us know how you think it should be, how it should be pronounced. But this project, whatever you want to call it, brings some neat capability. It lets us actually think about, okay, I've got many clusters available. Clusters are only as important as the workloads they run. And how do you make them more valuable for workloads? Make them able to connect and communicate more effectively. So whereas if you think about a traditional Kubernetes cluster, you've got networking that extends across the cluster, right? Pods have a certain network, services within that cluster have a certain network. And even though pods, containers run on different nodes within the cluster, they have a consistent networking layer. Submariner just extends that concept out and says, hey, we should be able to do this across any number of clusters. In this picture, we've only got 2, but clearly, as Randy has already shown you, it's really easy to stand up many clusters and bring them under management. And with Submariner, you'll be able to actually bring those clusters into their own consistent networking domain. Under the covers, the way this works is through, and let me go ahead and put this in present mode in case some of these pictures and icons haven't come across clearly. We've got clusters. It presents this logical view of networking.
Am I the only one that's not seeing a screen share right now?
Oh, even better. Let's see here. Can you see it now?
That sets off your alarms?
Apparently so. Apparently networking is the way to go here. Let me bring this back and let me see if I can.
It's the Internet of Things, and they're all tied together.
Share screen, set off alarm, off you go. Yeah, screen is visible though.
Okay, I think we're seeing a deck now, but Michael had to maybe chase down an actual fire alarm. I've never seen demos fail in real, actual catastrophic ways, just mostly like code related.
Right, like, yeah.
Mundane ways.
I can talk on this slide if you want, Scott.
Yeah, go for it, Raf. It's all you.
Yeah. Oh, we went ahead one. Yeah. So this one, yes. Submariner gives you a way to create a network tunnel between clusters. In particular, as you know, with OpenShift, we create an overlay SDN. That's where the pod network is and where they get an IP from, right? So now with Submariner, you can create a network tunnel between these SDNs in different clusters. It's like putting a router, a switch router between these 2 SDNs, and now magically the pods can talk to each other. So you get 3 main features with this product. You get the basic IP to IP communication, which is called the pod IP networking. Then you get service discovery. So if you have a service in one cluster, you can discover it from another cluster using a DNS call. So very native to what already happens in OpenShift. You just get a different domain to do cross-cluster DNS lookups. And then you get load balancing also. So if you open a TCP connection to a service IP, you get load balance to the pods behind that service, but that service and the pods live in another cluster. And finally, you get a network policy for cluster-to-cluster communication. So you can still define the network policies that we are familiar with, but in this case, across clusters. I think this slides goes a little bit more in detail about how the network tunnel is actually implemented. So you pick some nodes to be the gateway, okay? And the network tunnel is implemented as an IPsec tunnel. So these nodes need to be routable between each other. The rest of the nodes don't have to be routable. And then the operator, the Submariner operators, changes a little bit of the routing rules in the normal worker nodes, so that when you try to connect to a pod in another cluster, the communication flows through the gateways.
I'm so glad you have a picture, because I wouldn't be able to do any of this. This is remarkable. Thank you for having people like Rafa and Ryan Cook in this world that can do it. Do you want to start your environment, Rafa, where you've got a demo with the CockroachDB scenario?
Yes, I'm gonna.
Oh, I don't know if you had slides in front of that, but I'm ready. I'm on the edge of the seat.
Real quick. So you should be able to see my screen with my presentation here. So I want to present this idea of cloud native disaster recovery. This is an idea I've been reasoning upon in the last months, and I'm coming up with this definition to make a little bit of contrast between traditional disaster recovery and cloud native disaster recovery. So in traditional disaster recovery, in most cases, the disaster detection there is a human decision behind triggering the disaster procedure. So we see that something is going wrong, we decide, okay, it's time to kick off the disaster recovery procedure. It's a human decision. In cloud native, we would like that to be completely autonomous. So the system detects that one of the data centers is down and reacts to that. The disaster recovery procedure in traditional disaster recovery can be automated. Sometimes it's automated, but many times that I see, it's a mix of automation and human actions. We want it to be fully automated. RTO and RPO, which are the main KPI to determine how good your disaster recovery is, and stands for time that the service is down, and how much transaction time do I lose. RPO means how much back in time my state is when I recover. We want them to be either 0 or near 0. So we don't have discontinuity in service, and we are always completely consistent. We never lose state. And when I was explaining this to another audience, they told me, oh, these statements are too bold. We can really be 0. No, I'm not selling here. This is scientifically accurate. We are going to have 0 downtime, and near 0 downtime, because the global load balancer needs a little bit of time to reconfigure itself, but 0, absolutely 0 data loss. Also, traditionally, the process owner for defining this disaster recovery procedure is around the storage team, okay? But in the future, I think this responsibility will move to the application team, and they will be responsible of deciding how their application is and it needs to deal with disaster recovery. And then traditionally, the main technical capabilities that enabled the disaster recovery procedure were found in storage, right? So backups, volume sync, this kind of capabilities. But in the future, I think the capabilities will be found in networking. And east-west communication is very important for this new wave of application to establish clustering. So a database that cluster across different regions. And Submariner is a way to establish this east-west communication capability when you're running on OpenShift. And then a global load balancer that can sense the health of the application that is load balancing. So a smart global load balancer that can do this autonomous disaster detection are the capabilities that we're looking for. So going ahead with the demo, this is the infrastructure that I prepared. So here, if you can see my pointer, I have a control cluster. I just learned that I should call it a hub cluster. but it's the same concept. It's where Submariner is running. It's what I use to set up the other clusters that are running in 3 different regions in AWS. And I also have in this cluster a community global load balancer operator, which will observe what these clusters are doing and program the program our Route 53, okay, which is our global load balancer. It's the DNS in AWS. And then in this cluster, what I have prepared is the tunnel, okay, the Submariner tunnel. So they're all connected. Cluster 3 is also connected with cluster 1. So that's where we're starting from, and I'm gonna show you. Here I have my clusters. So the local cluster is the hub cluster, and then I have these 3 clusters. And I love the feature that Randy was showing a minute ago. Yesterday, this cluster were not up to the latest. So I selected all of them, and then I click this button here that now is grade, and I just kicked the upgrade for all of them at the same time.
Rafa, hey, would you go ahead and zoom up your browser a little bit?
Yeah, thank you.
What do I need to do?
Zoom in.
Zoom in. Okay. Yes.
Yeah. Control ++ a couple times. Yeah.
Okay. So I was saying I selected these 3 clusters and upgraded just with a single click. It was really cool. So next, what I did on this cluster, I deployed CockroachDB. So CockroachDB is a new SQL database that allows you to deal with these geographically distributed situations. And it's able to maintain consistency and availability when some of its instances go down, okay? It has other interesting features like linear scalability and essentially full consistency when there is an outage. It's able to reorganize the internal data structures that it manages. So the way I deployed here is there are 3 instances for local leader detection, and then there are local quorum, and then there are obviously 3 regions. So for a total of 9 instances of CockroachDB that form a logical database, a logical instance of a database. So we can see it here. I have it. Oh, I can't change it out. Okay. So I have it here. This is a web application served by the global load balancer. So I'm not sure exactly which regions is giving me this UI, but it's showing me the state of the CockroachDB database. And I can see that it tells me where the regions are. So this database has some awareness of the geography where it's deployed. Okay, so now I'm gonna kick off some workload on this database. Okay, so I have 3 clients that are set up in this way.
Hey, Rafa, will you do us a favor? It's sometimes the audio is getting a little loud when the microphone is too close.
Okay,
but if you leave it at your chest, Chris can adjust the volume so that it's perfect for the listening audience. Thank you.
All right. So I have a client per region that is pumping transactions to the database. Okay. This is the TPCC standard benchmark test for transactional database. So you can use this to measure how good the deployment of CockroachDB is. But we don't care about that now. We just want clients to be doing some operations on the database. And what we're going to do is to take out a region by isolating the VPC on which the OpenShift and CockroachDB are installed, and we are going to observe how the CockroachDB cluster reacts. Okay. So This is where the demo may go wrong. So let's let's hope everything is fine. Okay. So first of all, let's check.
Everybody starts focusing in. They're like, "Oh, really? Okay, I can't wait."
So as you see, we are pumping these transactions. I don't need to explain exactly how the test works, but you see that we are getting stats on the latency. Now on this monitor here, on this console, I'm going to run the command that isolates the cluster on the third region. Okay, so I'm going to run.
And will you bump up the zoom on that one too, so we can see a little better?
On this one, I don't know how to do it. Let me see.
There is such a thing. Okay.
I want to say it's Control++ here as well.
Wow, it just died on me.
Oh, fun.
Okay.
No zoom for you.
Sorry.
this should come back up. All right, so it's here. So no zoom, I think. Let's see. There we go. Nope, I didn't see any. Oh, okay,
You're doing
just a little slow.
Thanks, man.
Okay, so you should be able to see a little bit more, a little bit better. So I'm gonna run first these two. Oh man. Okay. Okay. Just to make sure, let's see that the variables have been. Yeah. Okay. So these two commands will make will add these deny rules to all ingress and egress traffic from the VPC in which one of the three clusters is running. I think it's the one in the west region. So we now expect this. See, we're not receiving a stream of logs from this pod anymore. This pod was running inside the cluster because we lost connection. These two, you may see for a while some error, but they recovered pretty quickly. See, this one had one error for a second, and also this one had one error, but they're now continuing working correctly. If we go back to the console, we see that CockroachDB has detected that it has a problem with this region here, and in a minute it's going to decide that the region is actually down. But beside that, CockroachDB is still available and still continues to work. So no intervention on my side except making the disaster, right? But the service continued to work because it autonomously was able to recover. So no downtime, no data loss.
So hypothetically, if that one cluster had all of the fire alarms in its house go off at the same time, right in the middle of a live stream, then the other two clusters could still pick it up and continue to work as it is. Is that what I heard correctly?
Right.
Okay, right. That makes sense.
Now, if you have ever been in a real disaster, you know that it's painful to run the disaster recovery procedure and start your workload in some other data center. But it's almost as much as painful also to do when the data center is recovered, the original data center is recovered, to re-swing back the workload where it used to be. So instead here, we're going to do the same thing. We're going to re-enable the traffic between regions to the third region, and we're going to see that the cluster just autonomously recover without us having to do anything. So also the operation of when things return to normality, it's done, it's handled automatically. So let me grab the script here. So again, we are now doing an allow rule for ingress and egress in that VPC. Okay, so the cluster here should sense this. Well, my computer is now exited because this pod died, and now it realized it. And so this client died because this test is not resilient to this kind of failures. But if you had a client that it was actually receiving traffic from a global load balancer, like a front end, when the front end comes back up, it will start serving again. Okay, and here Cockroach should come back, should start recovering these under replicated ranges. These are, I think, the word that Cockroach uses for its own partition. And as you can see, these other clients have kept working without any issues. I don't know if we have time to wait for these under replicated ranges to recover fully. Yeah, Scott, if you want, we can come back later to this.
I think we should let it percolate. And then I think there's another opportunity. We'll come back to it later.
Yeah.
It's tremendous. I mean, the work you've done to build that out, knowing that RHACM includes the Submariner tech preview code, knowing how that's all coming together with multi-cluster, opens up a lot of opportunities. I've seen Ryan cooking up some other interesting scenarios. Sorry, I'm on a dad joke roll this week, so I'm going to keep it going high. Ryan, do you want to take the screen share and show us what you've been working on with Scribe? And you might be on mute.
Definitely on mute.
Okay.
Here we
All
go.
right.
There we go.
So Scott, you were not lying. I'm just showing the screen right now.
Ryan, can you
because-
increase the font size though?
Oh, I
That's the
just
question.
built out these clusters in the last, I just finished a couple minutes ago. So let the panic and fun begin.
Yes, love it. So do we need some more fire alarms, or are we actually cooking with fire here?
I think I had my own mental fire alarms going off, but
It's fitting. We have these disaster recovery scenarios with actual maybe possible disasters going on.
yeah, see, I don't have a fire alarm. I just have my child next door blasting music. So I have my own little disaster going on.
Classic.
So just to kind of set context of where I'm going to start off today. I come from an ops background, and a lot of us have been there. Pager goes off at 3 a.m. and you have to respond. Very early on, when I first saw ACM, it brought in some capabilities that would have made my life a lot easier back in the day. Just the ability to go from one data center to another without intervention. So what I'm going to do is today I'm going to show that, but I'm going to add in this component called Scribe. So to kind of start things out, let's talk about Scribe. I'll put this in present mode. So what Scribe really is, and what I'll be showing today, is rsync within Scribe. And what we're going to do is we're going to have one site serving kind of as our primary data center, and another site will be our failover data center. And what this rsync capability is going to do is it's going to replicate our storage just over and over on whatever schedule that we'd like to set at the time. For this demonstration today, I set a pretty aggressive schedule of every 2 minutes, send the data from Virginia to Ohio. So it's really cool just to see, how fast your mean time to recovery could be. And, that's really dependent on your application as well. One thing I do want to add in as well, I know Chris Short will be very excited about this. The replication is completely managed by YAML. You just take this YAML, shove it in ACM, ACM takes over. And so it's that GitOps capability of managed storage replication.
That's awesome.
And so what are some use cases? I've talked about disaster recovery, but you might have a data center where you're, say, for example, running OpenShift containers storage, and you might have a provider running GP2. Those kind of mismatch when it comes to storage, but with the use of Scribe, you can actually set up the replication between those two completely different storage classes. So to get things started, right now, I'm going to move this screen over here and exit slides. All right. And so today I'm going to show off this amazing DocuWiki site. Just going to write a quick hello to everybody. And what we're going to do is we're going to fail this application from Virginia over to Ohio. And as I showed off at the beginning of this call, this is a brand new cluster. So what we need to do is we need to add in our failover data center. So right now I only have a primary location. As you see, I'm going to try to zoom it so we can see some fun labels here, but the purpose is our DocuWiki application, which I just showed. And then the site equals primary. We're going to actually use that to do our placement of our storage replication. So I'm going to go ahead and import our failover cluster. And there's our purpose DocuWiki, and then our site is failover. So we're going to generate the command to kind of add our cluster in. I'm going to copy this and I'm going to go back to my terminal. I believe this testing is good enough. We'll just accept it as is. If it breaks, it makes the stream much more fun. So I'm going to export my kube config or figure out my context currently. All right. Wow. I can't remember how to Kubernetes today.
It's
Spelled export wrong.
Current config, or no, current context, excuse me.
Okay, so what we're going to do is we're going to add our failover cluster in. This is going to take a couple minutes just to get all of the, kind of required components placed. So in the meantime, let's go ahead and take a look at what we're going to actually do. Wipe that one out. So as I was saying at the beginning, we're going to kind of use RHACM's cluster placement capabilities. As you see here, we have cluster replicas set at 1. And I'm going to try to zoom this in even further. And what this means is if my application were to fail on the one cluster in which it's running, please run it somewhere else that is currently running. To me, this is the most powerful extra admin to your team ever. It's someone that's going to say, hey, we need to switch over without you actually needing to wake up at 3 in the morning and switch over. So what are we going to do with our data? So we're going to take our primary sub M1 cluster, which is using the GP2 CSI storage class, and we're going to send the data over to our sub M2 cluster running OCS. So it's really cool that we're actually going between 2 different storage class providers. And then lastly, I'm just going to show you a bit of the YAML, but we're going to take a look at that more in depth when we actually deploy it. So as you see here, this is the icon that you'll see within the operator hub when you go to deploy ACM or RHACM. And we're going to have RHACM actually place our replication destination onto our sub M2 cluster. And then our sub M1 cluster is going to be kind of our source of all of our data. So at this point, let's take a look and see if our cluster is loaded in. It's in a ready state. It's still starting a couple of the remaining pods, but it's nothing that would stop us from moving forward. So let's deploy some Scribe components. So by default, any OpenShift cluster automatically gets the Scribe operator installed. So the CRDs are available anytime a cluster is added into ACM. So it's really cool that that's completely automated for me. Let me see if I have a better export. There we go. Okay, so we're on our ACM cluster now. And what we're going to actually do is we're going to take and we're going to apply our replication YAML. So -F, and then we're going to do our ACM replication. And we first start out with, when we're using Scribe with the rsync capabilities of deploying our primary, or actually, I'm sorry, deploying our failover. The reason why we do this is because that failover is going to create our service address for us. And so when we go back to manage applications, you'll see the replication application within ACM that we just deployed. As you see here, it's going to begin to start populating throughout our cluster. You'll see this little box here turn green momentarily.
Nice. So you got a cluster imported. That was a cluster you just built moments ago. Applied your YAML to generate this, application resource, which is going to represent the failover scenario that you're about to drive through.
Exactly. And the cool thing about it, to kind of bring everything back together, I'm using Submariner as the pathway to send the data between the two clusters.
That's awesome.
And in this case, you're also using applications, but not actually deploying pods. Your application is just deploying some additional components, in this case, that replication destination. But it's not a traditional app as we think about deployments, pods, stateful sets, et cetera.
Right. And this replication destination is going to kind of create a Kubernetes job, which is just going to start up, shut down as it kind of sees fit, as it's needed. So as you see, our little checkbox turned green. And so let's go ahead and take a look at what was actually created. Going down here, went to the wrong one. The joys of life. Let's look at our actual YAML for our view resource YAML. So here is our replication destination. And the important thing to see here is that at our destination, we're going to use OCS as our volume snapshot class, as well as our storage class to, write our application too. And then down here at the way bottom, I hope you can see it for some reason. Oh, there we go. There is the Submariner cluster IP address that allows me to be accessed between the clusters using Submariner. And then finally, you'll see an SSH key. Because we're using rsync, it is SSH replication between the two sites. So let's go ahead and add this address and the SSH key to our repository. And this repository will be available after the call for everybody to kind of play with or poke at and see everything in there. So we'll get our replication. So as I said earlier, we are going to be incredibly aggressive with it, and we're going to try to replicate our data every 2 minutes. This is the fun part about the schedule. Depending on your application, you might not need to replicate it every 2 minutes, but it's simple Linux cron to be able to establish that relationship. And then lastly, we're going to take a SSH key from the failover cluster. That's a secret that's created by Scribe. And we're going to bring it over to our source cluster. You can actually, by default, bring your own keys, but I didn't want to load those into Git and then have my repository out there. And during the demonstration, somebody decides to mess with my cluster out in the world when they're scanning for keys. So let's go ahead and get secrets for DocuWiki in the context of failover. Oh, from sub M2. And then you will see that there's this secret here. So I'm going to take that and I'm going to output it to YAML. And then I'm going to write it to a file into our replication source, rsync, under a YAML file. So go ahead and take a look at this. As you see, it is an SSH pub, and here's the secret. I'm going to scrub out a couple fields before I load it into Git. Okay, so okay, and now within ACM, let's go ahead and create the source application. So what this is going to do is ACM is going to find the replication for the primary and then deploy all of those components onto our primary cluster. So going back to ACM now, this will update momentarily and we should see a primary cluster and it's going to get the SSH key and the replication source. So the cool thing is here, now there's going to be a volume snapshot that's going to be created on our failover cluster.
I like how Ryan says the cool thing when there's already been like 17 in a row, but just keep doing it. Keep wowing us with more cool things.
Hey, I'm just absolutely blown away by, the ability that ACM gives me to place all of my stuff without having to place it. I feel like I was somebody's GitOps tool at one point in my life.
You've lived that. You've been that.
I've been there. So, okay, so our replication source has been created. And what this is going to do, I'm going to split my terminal just so that hopefully I can see when the pod starts. And then we can actually see the replication taking place. And I will increase the font in 1 second. Okay. So if I can do a git pods on, actually get application source -n docu-wiki. And we're going to see that at 48, there is going to be a sync. So that should be like now. So we should see a Scribe pod being started momentarily.
Chris, do you have drum roll?
I wish.
And Zing in there too.
Chances are, if I had a drum roll, it's probably copywritten and would get nabbed, and we would get kicked off of YouTube or something. So I need to find like an open source sound effects thing.
Work to do.
Yeah.
All right. So at some point, it's going to be 148 or 248. Is that 248? And this should start. Just waiting. I feel like the waiting is actually more intense when it's live than,
Absolutely. Right. Like, we embrace failure on the show, but waiting is always harder when it's live. Yeah.
So let's troubleshoot live and see if we can see what's going on. Okay, so waiting for snapshot to be bound. It did the work while I was panicking. So let's see if get pvc-n docu-wiki. All right.
Category of good dad jokes. A watch PVC never replicates.
I think so. I think
good
that's
one.
the thing. It's almost like the tree falls in the woods. So, okay. So we have our application here. Let's see, okay, let's see. So while I dance in the background, why don't we just Rafa, if you want to show the populated CockroachDB.
Let's do that.
Yeah.
Yep.
Just I'll have something in a moment.
All right.
I'll take the screen again. Yeah, so a few minutes after we stopped watching this, it actually recognized that these clusters were back alive. And if you remember, we had about, I think, 80 under-replicated ranges. And very quickly, they came back to be fully replicated and healthy. So the cluster, CockroachDB cluster, I'm not an expert, so I'm not probably making justice at describing how it works. But once it recognizes that those nodes that were not reachable are back online, it will essentially resync the state with those nodes, and they are back to serving workload. So if you want to be able to replicate this demo, we have all the information here. I'm not sure, Chris, how we can share these links, but
give me access to slides. I can drop them in.
Yeah, actually there is a spell. Yeah, and I'll give you access. So it should be able. They should be available later. If you want to try to replicate this, anyone should be able to run this demo.
Nice. And I know, Raf, you've been working closely with the CockroachDB team on some of the performance characteristics.
Right. Thanks for reminding me that. I actually wanted to thank them because they have been very helpful in advising me on how to set up this cluster, how to run the demo, how to run the TPCC test to get good results. It was overall a wonderful collaboration. Maybe while we're waiting, a point that maybe I didn't make well enough is these pods, they all talk to each other. They don't talk through a load balancer. Each one needs to be able to talk to the other one individually. So they establish a web of connection or a mesh of connection. And this mesh is enabled by the Submariner network tunnel that we talked before. So it's nice to see how RHACM allows you to create the clusters and deploy the applications on the cluster, and Submariners allows the communication between the application deployed in the cluster when the application needs to do east-west type of communication. And then if you have a load balancer in front of the clusters, you can now serve workloads in an active way.
Yeah, it's been interesting. I mean, I've been watching your work from afar, but seeing the improvements and then understanding the approach, articulating the performance characteristics along the way, troubleshooting some of the latencies, but getting to your original goal, slide 2, which you've talked about, which is no human intervention, right. RPO near 0. I mean, you're like really pushing that model, which I think is pretty unique. It's awesome to see it coming together with these tools.
Yeah, thank you. And that's what I want to be able to enable for our customers, right? It's this RPO and RTO near 0 is something that only the big web scaler like Google, Facebook have, or the new, unicorn startups. But I think we have now enough technology that is accessible to everyone, so that if you are willing to invest a little bit of time, you can actually set up this kind of architecture in more traditional enterprises. And so I wanted to showcase how that was possible with this demo. There are obviously other products that can do it, but Cockroach turned out to be very good at this kind of, handling this kind of scenarios.
Yeah, almost a perfect fit. Ryan, should we cue back over to you or take some questions from the audience?
All right. I don't know if my mic's still hot. Is my mic still hot?
I can hear you.
Yep.
Okay. All right, cool. So it's actually helpful to you to define a volume snapshot class if you intend to use one. So my issues were around volume snapshot class not being kind of defined. So if you look here, volume snapshot. Let's see again, volume snapshot class. Dash context. Okay, so we should have that. If I don't get a volume snapshot in a second, then we may have to just go to questions.
Well, either way, we can definitely handle some questions on there. There were some good ones in the chat. Chris, I don't know if anything bubbled up too.
Yeah, let's see here. Start back at the beginning.
There's a couple that I would jump on. I think one of the first ones that popped out in the chat was about ACM and high availability.
Mm-hmm.
So, and the question was basically, is ACM highly available? It is highly available across availability zones. So out of the box, when you deploy it, it will take advantage of anti-affinity zones within the cluster. If you are in a hyperscaler cloud, it'll put a set of pods across different AZs. If you don't have AZs, it'll at least spread them across different nodes. But really the question was asking about multiple data centers or region, high availability across multiple regions. And for that pattern, you can have two hubs that are sourcing the same policies from GitHub or from an object store. We saw that pattern with a subscription coming out of a Git repo, or we've seen that in prior Twitch streams. So you can definitely do that. What we don't have out of the box today is the agent failover behavior. So if I have cluster in region 1 attached to hub 1, cluster in region 2 attached to hub 2, they won't automatically fall back over to the hub. We've experimented with architectures for that in the past, but the complexity around it made us shy away from trying to put it in a product. But if you're interested in or have real use cases where you're trying to do that, reach out to us and let us know. We'll work with you there. And then the other question was about service mesh and Submariner and how those two things are related. Now, really, they're somewhat orthogonal, right? Service mesh brings a set of capability around registration discovery, and Submariner is really about establishing the network bridge. I wonder, Rafa, based on the applications and what you've done with CockroachDB, have you found a place where those two intersect really well, or some examples that show them intersecting well?
I think, well, I see the service mesh mostly working at layer 7, and Submariner is working at layer 3.
Mm-hmm.
Yeah, it's true that you can also use the service mesh for doing TCP, but really where it shines is layer 7. Yeah, our product roadmap has support for multi-cluster for the service mesh in this year, sometimes probably the second part of the year. We haven't yet explored whether Submariner is a requirement for that or not. It may be that it isn't. So if you just need to do layer 7, you may be able to do it without Submariner. But I think in the end, use together will allow you to do to handle both the layers 3, 4, policies, network policies, and layer 7 configurations. So they definitely can work together. I have not heard yet of use cases where they are needed together.
Okay.
Yeah.
And Chris, I don't know if there were any other questions, or Scott, that you guys noticed that you wanted to draw out.
So we got a question on Discord yesterday, and I'd like to ask that, if you don't mind. The user's having problems with distributing secrets. Imported an existing cluster. When I do that, though, there is no cluster deployment to reference in my sync set or select your sync set. Am I just missing something? Question mark.
Great question.
Yeah.
So if you're using Hive, sync sets are a way to push content down, just to kind of make sure we're on the same page with what's going on there. The cluster deployment API object is what we use when we create or provision a cluster. You create one, and behind the scenes, Hive will go off, have a provisioner job. You're off to the races. We use a sync set to deliver the initial agent payload into that cluster. But once the agent from Open Cluster Management connects back to the hub, it's a pull model. It's connecting back to the hub and asking for state to apply. And we do that partially so if there's ever a disconnect, that cluster can continue to enforce policy or other desired state. So if you simply import a cluster, wasn't created through Hive cluster deployments, then you can actually use a couple of different ways to deliver content to it. In the product, we really focus on that concept of a subscription. So you saw Ryan use that to deliver content down. And in that model, the subscription comes from a source, GitHub, object store, etc., Helm repository, and you match it to a placement rule, and ACM will automatically deliver that content into the target cluster. You can also use a policy. So if it's something that you just want every cluster to have as sort of a foundational bit of config, it's not specific to a particular application, a policy works in a very similar way. If you want to go underneath the hood, you can take advantage of an API object called manifest work. That's a very low-level primitive that we use to deliver part of the agent mechanism, and manifest work is declared in the Open Cluster Management API repo. So you have to put that specific object in the specific namespace for the specific cluster. So it's not as flexible as policies or apps, which really use placement rules to dynamically place and adjust content. But once you've imported, sync sets won't work because they don't have the same information that they would have for a Hive cluster deployment. But what we typically walk users through is using policies and apps.
Makes sense.
Can I add a consideration on this?
Yeah, sure. Go ahead.
So secrets and GitOps is still an evolving, situation. There aren't always, there aren't perfect solutions there, but it's evolving. The other thing to keep in mind is, at least that I notice, is when you start having multiple clusters, managing them with RHACM, you need to be able to make sure that the same secrets are propagated to all of the cluster where they are needed. For example, an application that needs to connect to a database and it's living on different clusters may need the same secret to connect to that database. Or I may have to create certificates in all of this cluster from the same PKI so that as trust can be established between the pods that live in this cluster. For example, in my example of CockroachDB, all the communication is over TLS. And so I had to generate all the certificates from the same PKI. So you need to find a way to have a source of truth for your secrets that all of your cluster can be connected to, and from where you can source all of your secrets. I like to solve this problem. I personally like HashiCorp Vault a lot. I think it's a good tool for solving this problem. I'll stop there.
I agree with that. I think Vault's a very handy tool.
Yeah.
You can also use an object store bucket and create an ACM channel to the object store bucket, so you can protect the object store bucket so it's not storing secrets in Get. Another technique I've seen is using the sealed secret API, which is a community API. You encrypt the payload with the public key of a particular server, and when the sealed secret arrives at the server, it's decrypted with the private key, so it's easy to protect it for a particular cluster. We're interested in feedback. One of the things we have kicked around in the labs is creating a multi-cluster sealed secret. You'd encrypt it once with a key on the hub, and then based on placement behavior, we would basically re-encrypt it with a public key for every cluster that we distribute it to, so that you don't have to encrypt the same sealed secret yourself for every potential cluster that's going to need that certificate or secret information.
Awesome.
It's a good topic. That's probably its own hour-long session.
Yeah, I feel like we could get Christian Hernandez from GitOps Happy Hour and us all together to talk about secrets in GitOps just in general and see how, that conversation pans out. That might be a good opportunity in the near future. Yeah.
Hey, that was a fun day. Rafa and Ryan, I appreciate you guys. And Randy, thanks for the demo, to kick us off. You guys are phenomenal. Chris, thanks for hosting us. Do we want to, Ryan, is anything else happening on your screen or anything we want to look at, or are we all done there?
No, I think this is just going to force me to come back in the near future. So
Sweet.
Be prepared.
Perfect.
I'll gird something. So yeah. Thanks all. I believe I'll share the link to this in Discord. So the person that asked in Discord, I think they're watching, but I don't know for sure. I think that covers it as far as questions go. Anything else anybody wants to share before we sign off here?
Appreciate everyone's time and a good conversation.
Yeah.
It's been great.
No more fire alarms.
Yeah. Good luck.
Until next time.
Yeah.
Until next time. Yeah. Cluster deploy, fire alarm, go. Okay. So thank you all very much for joining us today. Thank you all for watching out there. It's been a very fun day of streaming here on OpenShift TV. Be sure to check us out tomorrow morning, starting out with the Level Up Hour at 9 a.m. Eastern. and we'll be rocking and rolling from there. When in doubt, check our calendar. I'll drop a link to that in chat right now. And until next time, everyone, stay safe out there.
Cheers. Thank you.
Bye all.